Hello friends. Now in the previous discussions, we have studied about the different methods of distillation, that is simple or differential distillation, and then we have learned about the flash or equilibrium distillation. Now in this presentation, we are going to discuss about the rectification or fractionation distillation. So this is one of the most important method, the famous method, and it is mainly used or commonly used in the industries. So this method gives you the almost pure product, and that is why it is common in the industries. The majority of the applications of this method is in the petroleum refineries, petrochemical and chemical plants, and natural gas processing plants. For example, what we have discussed in the first presentation of this distillation series is that crude oil is going to separate into number of substances like white petrol, kerosene, diesel, oil, waxes, coal tar, etc. So that is one of the best example of this rectification distillation. In this presentation, the contents are rectification or the fractionation distillation setup and the details of this process, then the material balance equation for the binary mixture, and then we are going to learn about the rectification on ideal plate. So students should give the answers for explaining the fractional distillation, for derivation of material balance equation or writing the material balance equation, and then description about the rectification on ideal plate. So in the first slide again, we have already discussed about these two ways of distillation, that is distillation without reflux and distillation with reflux. Now in the previous presentation, we have discussed about distillation without reflux through simple or differential distillation and through flash or equilibrium distillation. Now the second way of distillation, which is more important than the previous one, is distillation with reflux. So we have already discussed about what exactly the reflux is. So the part of that liquid component from the condensed liquid, if it is sent to the top of the plate of this distillation column, then that liquid part is called as liquid reflux or simply reflux. So this distillation is running with the help of reflux and with reflux. So the best example is rectification method or fractionation. Now why this distillation method is called as rectification? Because the enrichment of the vapor stream as it passes through the column in contact with flux is termed as rectifications. So it is one of the technique, that is rectification with reflux. So whatever the part of this condensed liquid is contacted with these vapors, and then rectification can be done, and that is why this process is called as rectification distillation or simply rectification. Now in general, it is operating in continuous manner, that is why sometimes it is also called as continuous rectification. And fractional distillation is a distillation technique used to separate a liquid mixture containing components having closer boiling points, so into pure components by a series of vaporization and condensation cycles, depending upon the length and efficiency of the fractionating column. So we are converting the MVC fractions and LVC fractions or liquid fractions and vapor fractions. So in this process, if you observe, there is a vaporization and simultaneous condensation. So it is a simultaneous vaporization and condensation techniques. It is also called as the number of cycles in the column, that is of vaporization as well as condensation. So this distillation technique may be called as fractionation or may be called as rectification. If you are using this distillation technique in the petroleum refineries or petrochemical, then generally it is called as fractional distillation or fractionation, because we are separating the different components or the fractions from this plate column or pack column. So we are separating these fractions as a substance or byproduct or main product, and that is why this technique is called as fractional distillation or fractionation. And when we are going to rectify, it means, for example, if this process is in the alcohol industry, then our main motive is more pure product, high concentration product. So generally in the alcohol industry, we are deriving the 95% or 95+% alcohol in the alcohol industry. It means we are rectifying that vapors in terms of more volatile component, and that is why when this distillation technique is used in the alcohol industry, normally it is called as rectification, and if it is used in the refineries or petroleum or petrochemical industries, then it is called as fractionation. So what exactly happened in this setup? So let us discuss. So there are main three components in this setup, that is column itself. So here it is column, then condenser, and then reboiler. So column, condenser and reboiler are the major three components of this distillation setup. Now we are going to feed this feed, that is liquid component mixture, into this column at the feed plate. So the feed plate position depends on the conditions again. So feed may be in terms of cold liquid, feed may be in terms of mixture of liquid and vapors, feed may be in terms of vapors, or feed may be in terms of superheated vapors, etc. So depending on the feed conditions, the feed plate is going to decide. So after feeding this feed, that is liquid component mixture, into the column, if it is in the liquid phase, so obviously this feed is flowing towards the reboiler, and in the reboiler, with the help of low pressure steam or medium pressure steam, that liquid feed is going to heat. So after getting the heat from the steam, the liquid components are going to convert into vapors, and then this vapor mixture, mostly of MVC at the initial state, as its boiling point is low. So MVC rich component or MVC rich vapors are going to the column again, and then these vapors are flowing in upward direction. So as its density is lesser than the liquid droplets, so obviously the vapors flow is in the upward direction, and these vapors are then flow through the condenser. So in the condenser, temperature and pressure is constant, and coolant is provided for the condensation technique. So with the help of coolant, these vapors are converted into the liquid. So if these vapors are converted into liquid droplets at constant temperature and pressure, then that process is called as condensation. So after converting these liquid droplets are accumulated in this reflux drum, or it is also called as accumulator. And from this quantity, if it is needed, then the part of the condensed liquid is going back to the top of the column, that is at the top plate of the column. Then that part which is going to the top of the column again, that part is called as liquid reflux or reflux only. And if the required purity is achieved in the first cycle itself, then that accumulated liquid or condensed liquid can be drawn or withdrawn as a top product, or it is also called as distillate. If the required purity or required composition is not reached, then again this liquid reflux is contacted with the vapors and more volatile components are again come to the condenser, and this cycle is going on up to the requirement of our purity range. In the same way, this feed is fed through the plates, and again it is going to the reboiler, and again these vapors are contacted with the reflux again. So there are two sections of this main plate column. That is, one section is above the feed plate. So this part is called as rectifying section, which is above the feed plate, and the part which is below the feed plate is called as stripping section. So why this part or the sections are called in that way? The rectification is the technique where we are rectifying or wash out the vapors in terms of MVC, and that is why this MVC component reach is in the above section. So that is called as rectifying section, and the process is called as rectification. If the LVC rich components are there, it means from the liquid components and from the vapors, if the LVC is going to stripped off or remove, then that process is called as stripping or the deabsorption. So now we are removing the LVC components from the liquid itself, and all these LVC rich components are reaching towards the boiler, and the MVC rich components are reaching towards the condenser. So as the rectification is going on in the section above the feed plate, that is why this section is called as a rectifying section. And the stripping process is going on below the feed plate, that is why it is called as stripping section. So these are the main two sections of this plate column or pack column. Now this liquid as well as vapors are at the bubble point and at the dew point respectively. It means the liquid, if it is heated or its temperature is increases, so as it is at its bubble point, obviously the more volatile component is going to start to vaporize, and the vapors are at its dew point. It means if the temperature is reduces, so obviously the vapors are going to convert into liquid droplets, that is called as dews. When we are feeding this liquid component continuously, and when this simultaneous vaporization and condensation is going on, and that is why it is also called as simultaneous vaporization condensation technique. So depending on the purity or depending on the concentration what we require in the distillate as a top product or the final product, the cycles are going on, right? So let us discuss what exactly happening on the rectification plate, that is ideal plate, or what exactly the rectification is going on the ideal plate. So first of all, we must know about the ideal plate and its rectification. But before that, on the basis of this diagram, I am going to write the material balance equation, that is overall material balance as well as individual material balance. So as we know that from this diagram, this is the feed here. So it can be indicated as capital F, and here it is a distillate, so it can be indicated as capital D, and bottom product it can be indicated as W as a waste. And if you consider these symbols, then we can write the overall material balance equation as feed equal to distillate plus bottom product, or it is also called as waste. So feed can be indicated as F, then distillate can be indicated as capital T, and bottom product or waste can be indicated as capital W. In the similar way, we can write the individual material balance for MVC component. Suppose in the binary mixture, A is a more volatile component, then we can write the individual material balance for MVC or for A as the A in feed equal to A in distillate plus A in bottom product or waste. So A in feed can be written as F into its fraction. So we are considering XF as a MVC fraction in the feed in liquid phase. Then in the distillate, it can be written as D into XD. So XD is the mole fraction of MVC in the distillate, and W into XW. So XW is the mole fraction of MVC in the waste. So these are the material balance, that is overall material balance equation, and material balance of MVC for the rectification or fractionation technique. Now the rectification on the ideal plate, that is one of the additional concept in this rectification technique. So if you observe, we can consider one plate as an ideal plate. Suppose this plate N is an ideal plate, and this plate N minus 1 is above the ideal plate and N plus 1 below the ideal plate. So if you observe the nth plate composition, what exactly the input for this plate N is. So this is the input of this plate N, right? And what exactly the output is? So output from this ideal plate is this one. So if you observe this plate nth composition of liquid and vapors, So downward arrow indicates the liquids, upward arrow indicates the vapors. So from nth plate, the vapors flow rate is, or the molar vapor flow rate is capital V suffix n, and the composition for this Vn is Yn. In the same way, the liquid composition is Xn and liquid flow rate for this nth plate is Ln. And the inputs on the nth plate is the liquid flow rate from the above plate, that is n minus 1, and that is why the suffix are L suffix n minus 1 and small x suffix n minus 1. It means the liquid droplets having the liquid flow rate as L suffix n minus 1 and having the composition xn minus 1 is dropping towards nth plate. And in a similar way, from the bottom plate or the below plate from the nth plate, that is n plus 1, the vapors are coming towards the nth plate. So that is V suffix n plus 1 is the vapor flow rate of these vapors which is going towards the nth plate, and the composition of these vapors are Yn plus 1. Right? So if you consider this nth plate as an ideal plate, then the rectification or the simultaneous vaporization and condensation is going on in this way, right? So we can draw the TXY diagram like this, and from this diagram you can understand that this point indicates the A and B points like Xn and Yn. So this is Xn, this is Yn, because we know that this diagram or this curve is nothing but a temperature versus X curve, and this is temperature versus Y curve. So on this curve Xn is there and on this curve Yn is there. So Xn is this one, that is the liquid composition of this nth plate, and here vapor composition of this nth plate, right? If you observe the different composition, that is C. So what is C indicates here? That is Xn minus 1. So what is Xn minus 1? We know here this is the liquid composition of the n minus 1 plate, right? So here you can understand the composition again, and in a similar way D indicates Yn plus 1, right? So what exactly Yn plus 1? This one. So the vapor composition from n plus 1 plate. So all these compositions can be indicated on this TXY diagram, and we can understand the composition of MVC is increasing in the above section, that is in the rectifying section, and which is indicated in this direction because here it is a D point that is above the other points, and D is nothing but the Yn plus 1. So when these vapors are going in the rectifying section or in the above section, these vapors are going to increase the composition or concentration of MVC, and in the reverse direction, as the liquid are going towards the bottom side, the LVC rich components are there. So when we are moving in upward direction, MVC rich components are there normally in the vapor phase. When we are moving towards downward direction, the components are LVC rich components, and the temperature at the bottom is higher than the top, right? So this is all about the rectification process on the ideal plate. Thank you.